Hello, my name is Marcela and I work in Rossum as AI research engineer. And today I will tell you something about challenges of text extraction. So in Rossum, we do intelligent document processing with focus on invoices and other transactional documents. And for that, we have our own transformer model, which we call T-LLM, and that stands for Transactional Large Language Model. And it's part of our Aurora engine, which is here in this super detailed schema. And how it works, first we read the text, then we create something we call spatial text, which is a data structure capturing all words and their positions on the page. And that is then the input into that transformer model, and that's where all of the Aurora magic happens. And one thing you should know about our T-LLM is that it's encoder-only model. So it's a generative model. We use it only for classification, so it basically tells you this part is address, this part is amount, etc. So what that means is that it doesn't suffer from hallucinations, which is great. It can't predict anything that's not in those in that input. On the other hand, it's like the quality of the text extraction is extra important for us, because if something is not predicted in that phase, it will never be fixed, it will never be predicted. So that's what I'm going to talk about. And what we do, Rossum supports both images and PDFs. So if there is PDF with available PDF text layer, we use that. If not, we use OCR, which sounds very simple, right? And I will dig a little bit deeper. And spoiler alert, the tricky part is that if available. But first, disclaimer, I wanted to show you a lot of funny examples, but those come from our support tickets, and I'm not allowed, naturally, to show you any customer data. So I just I did my best to recreate them in a way that it still captures the essence, but I'm not showing you something that I'm not supposed to. So all of those examples are a bit fake, but I will just pretend that those are real, and they are very close, trust me. I will start with OCR, and we had our own OCR solution, but we needed to support other languages, Sanskrit, like Japanese, Chinese, etc. So we decided for third-party OCR, which also supports handwriting and vertical text, which is amazing. So we just went with it. And last year, we spent over a month trying to improve our PDF processing pipeline. And I've been asked a lot if it's even necessary, if that OCR is so great, we can just ignore PDF and use OCR everywhere. So the question was basically, is OCR solved? Is it good enough? And we will try to answer these questions together now. So this is the first example. Here, the OCR just ignored that part of that handwritten text which is there. It read only the first and the last digit, which might be not ideal. But well, to be fair, it's handwritten text. It's sometimes hard for humans to read that. And there's no PDF text layer anyway. So maybe that's okay, maybe OCR is good enough at least for printed text. And well, let me explain what you are looking at, because I had to erase all of those words. So those blue rectangles are detected words, which our OCR detected. And the red ones are those that are there but were ignored. And the issue is that those documents have large diagonal watermarks, which are very, very problematic for some reason. Well, it's overlapping text, so it kind of makes sense. In the left case, it got so confused that that line is weirdly warped, and some words were completely ignored. On the right side, amount was ignored, which also might be problematic. But those are overlapping words, which is probably hard too. So, okay, maybe OCR is good enough at least for printed text with no overlapping words. And here is represented. This is actually a very common issue, and that is words with single text with single characters, single digit or single letter, are often ignored, and that's extra prominent in tables, which those columns with all zeros, for example. So they are not detected at all. They are just missing, and as I already mentioned, we cannot fix that later. They are just gone forever. Okay, so maybe OCR is good enough at least for printed text with no overlapping words and no tables. And there is another example. This is funny to me because the OCR that we use kind of prefers consistency and has issues with reading words which are mixing letters and digits, like here. This one, it's nice one, but it's between D and C, so it was read as I. And below it, it's U, but it's between 1 and 7, so it was read as O. And those texts are kind of rare in like real world, but in documents that we process, those are really common. So this is a big issue. So maybe OCR is good enough at least for printed text with no overlapping words and no tables and no codes mixing letters and numbers. And I guess that you can already see where I'm going here. So to be fair, those examples were cherry-picked. Those are quite rare in general in the sea of document that we process. So maybe we don't need to care too much because we don't expect 100% accuracy from machine learning models. So we expect there are some mistakes always, right? But unfortunately, we really need to care because even though these issues are kind of rare in general, there might be customers which process one type of documents, and that error is always present there. So that's bad for them, and so they care, so we should care too. So the answer to the question is OCR solved is not for us yet, unfortunately. But as I already mentioned, we process PDFs also, so we can use that PDF text layer, which is there. But the issue with PDF is that it was made originally for printing and rendering of the document. It basically contains just instructions for rendering. And you know that you can select the text and copy-paste it, but the text that you copy-paste doesn't have to correspond to the thing that you see rendered, which is wild. Why would anyone do that? Well, I don't know, but it turns out that you can even play Doom in PDF, and that's the issue. It's too powerful. It can do so many things, and everything is possible. And if everything is possible and you process millions of documents, you will see some weird things, and I will show you some of them. This is the first example from one support ticket. I really like this one. Yes, this is PDF text. This we didn't run any OCR on this, and those blue letters are what it says that is what is in the PDF text layer. And what happened here? Well, you probably can see that it doesn't look like nice digitally born PDF. It looks like it was printed and then scanned again. And that's exactly what happened. And it was scanned probably with some scanner with some amazing OCR feature, which created that PDF text layer for it. And what happened here is that it was scanned upside down, and that OCR didn't recognize it. So that's the first common source of errors in PDFs, is that it's from the source, which is not which we don't want to trust. We have better OCR, so we want to use our OCR and not that. That's the first issue. Yeah, another one is some kind of broken encoding. That's what I already talked about. It's that happens when the text that is there in that PDF text layer doesn't correspond to the thing that you see rendered. And sometimes it happens only for some characters, like accents, which you can see in the first example. Sometimes the whole text is just wrong. Another issue is invisible text. Sometimes someone wants to add some extra information, some metadata to that PDF. And the best way, apparently, is to put it there as invisible text, which causes some issues for us. And actually, you can detect invisible text in PDF. It's possible. But in this case, what mostly happens is that it's, for example, white text on white background, so it's not truly invisible. And that's harder. And then you can have, for example, incorrect reading order. All the words are there, but ordered incorrectly, which is not a big issue. We can fix that. And lastly, this is the most common one, and that's that the bounding boxes are bad. The text is all right, but the position, which is like in that PDF text layer, is not correct. It can be, the first example is correct. This is nice. This is what we want. But it can be shifted. It can be too small, like the third example, or it can be too large. And that's worse for us because it can be overlapping with other text that's on the page, and that's causing a lot of issues. Then I have some examples of less common issues. And after more than 4 years in Rossum, I'm still sometimes surprised by creative ways to create broken PDF. You can have text outside the page with like negative coordinates or something like that. For some reason, it's possible. You can have like the page can be rotated, but the text is not. Just the rotation of the text doesn't have to correspond to the rotation of the page. And then my favorite one, it's not too common, but sometimes it happens that someone wants to write text in bold, and apparently the best way to create bold text is just to duplicate it and shift it a bit little so it looks bold, but and it's kind of similar to the way you would create bold text on old typewriters. So maybe that's the inspiration for that. And another thing, last one, mixing fonts in one word. That happens with sometimes capital letters with different font or different size, or letters with accents are different font. And the Python processing libraries that we use to read that PDF text just treat it as different words, like it doesn't belong together. So some post-processing is needed, and it's annoying. Okay, so I already mentioned that we kind of use both, that we decide if we want to use PDF or OCR, and that wasn't entirely true. Actually, we combine those two in most cases. So first, we have to somehow decide if we can trust the PDF. We do it in a few different ways. It's nothing super sophisticated. Then we always run the OCR, and we compare the output of the OCR and of the PDF text. And we kind of...
With this classification, whether to use for PDF or text extraction, is there are you using also the metadata? Because sometimes the greater the metadata gives you the good hint that it could be trusted or not.
Yes, that's what we used to use, and there were always some holes in that. Like we thought that we have it, and then a document came and it didn't work. So we can we used the metadata for that. And then what happened is, okay, this producer, which is in metadata, or creator, produces broken PDFs, so we will put it into blacklist and always OCR for it. So we had like this long blacklist of producer and wasn't ideal. So what works for us is that we compare the PDF text to the output of OCR, and we assume that OCR can be a bit wrong, but not completely wrong. So if those texts are little bit different, we assume that OCR made some error. And if they are completely different, we assume that it's the PDF that is broken. And that usually works very well. No, it's not 100%, but it's better than any solution that we had in the past. And then we do some other things, like I mentioned that invisible text or bad bounding boxes, and what that causes is that there are some overlapping words, which is like weird for us. It's probably wrong. So, and we don't know which one we want to keep and which one we want to throw away. So we remove everything, like both overlapping words, and just let OCR fill the gaps. And that's also useful for, like, PDFs can contain some embedded images, like often headers or footers don't contain any PDF text. It's just image. So OCR can read those, and we combine that together and get something like, we hope a bit better than OCR, pure OCR or pure PDF. So what I'd like you to take away from this presentation: first, don't trust your PDFs blindly if you don't know the source. And second, please don't create broken PDFs. And I'd like to end with this image, which is from one support ticket where in this case, rendering was broken because some fonts were probably missing, and just the whole page was filled with A's, and it looks like the document is screaming for help, and I can relate to that because that's how I often feel when I'm dealing with those support tickets. And that's all from me. Thank you for your attention. And